Hello everyone, my name is Divya, presenting our research paper titled How Will Drivers Take Back Control in Automated Vehicles? An empirical test of interleaving framework. Society of Automotive Engineers categorized vehicle automation into 6 levels, level 0 to level 5. The vehicle with the most advanced automation feature currently operate at level 2. So the next level of automation that we can expect in cars is level 3 automation. So what is level 3 automation? Level 3 automation features can drive the vehicle under limited conditions, which means when the vehicle requests control, the driver should take control of the vehicle and drive the vehicle. Our research work explored the transfer of control from an automated vehicle to the driver. A research paper defines the theoretical model for the transition stages during the transfer of control. The model demonstrates that transfer of control is a series of 10 explicit stages, not a single step. The model has 11 stages starting from stage 0 to stage 10. This paper focused on stage 0 to stage 6 only, which is the transfer of control from vehicle to the driver. Stage 0 represents the driver is working on a non-driving task while automation controls the vehicle. In our experiment, non-driving task is 20 questions task. Stage 1 is the external warning given by a system to the driver requesting driver control. We have a pre-alert followed by an emergency alert. Stage 2 is the disengagement for the first time from the non-driving task to start a period of interleaving attention between the non-driving task and the driving task. Interleaving is driver going back and forth between the two tasks. Stage 3 is the orientation towards the driving task. Stage 4 refers to the suspension of the non-driving task. Stage 5 is when the driver presses the button to take control of the vehicle. Stage 6 is when the driver controls the vehicle in manual driving. The two research questions that we formulated, first being, do drivers interleave the non-driving task and driving task as they take back control of an automated vehicle? If yes, how is the probability of interleaving affected by the time available to take back control? Second research question is, if drivers do interleave, what are they using the time for during interleaving? And how does this depend on the time available to take back control? Our research goal was to conduct a driving simulator experiment and extend our understanding of how drivers take back control from automation by exploring the steps that are involved in switching between the non-driving and driving task. Our experiment trial had 4 manual modes, 4 autonomous modes and 3 takeover requests. Starts with the manual mode. Each manual mode is about 65 seconds and autonomous mode is about 100 seconds. Mode transitions are indicated by voice alerts after a beep sound. Each participant repeats the experiment twice, one for 15 seconds and another one for 30 seconds condition. In 15-second condition, the time between pre-alert to emergency alert is 7 seconds, and after an emergency alert there will be 8 seconds time before the vehicle forceful manual transition. In 30 seconds condition, the time between pre-alert to emergency alert is 22 seconds, and after the emergency alert there will be 8 seconds time before the vehicle forceful manual transition. Participant can take control of the vehicle anytime after the pre-alert by pressing the button. If the participant fails to respond in the given takeover time, then the system forcefully transits to manual mode after timeout. Simulated driving environment was created using the BeamNG game and Logitech hardware. Eye tracker is used to collect eye data and front visual video. Laptop and PC is used by participants and experimenter to perform 20 questions task through Skype application. DLab software is used to collect the data from multiple systems synchronously. The 20 questions task is a guessing game. Participant guesses the randomly chosen item from the list of 18 items by asking questions to the experimenter. The experimenter answers yes or no to the participant questions. Among the 18, 6 items related to the kitchen are shown in the figure. Each item has a room category like kitchen, bathroom, living room, and further 2 additional characteristics that are used to ask questions and guess the items. We identified a measuring parameter for each stage. The timestamp of the start of automated driving mode is considered for stage 0. The first timestamp of the pre-alert message after the beep is stage 1. The timestamp of the first glance of the driver away from the laptop screen is stage 2. The timestamp of the first glance of driver at driving screen after the pre-alert is considered for stage 3. Last moment when the participant played the 20 questions task, which is the suspension, is considered as stage 4. Participant button press or system forceful transition to manual start time is stage 5. Start of manual driving after stage 5 is considered for stage 6. From the data, we identified 2 patterns. The patterns demonstrate the order of series of transition stages while switching from non-driving task to driving task. The patterns are named as interleaving pattern and suspension pattern. In interleaving pattern, participants followed the canonical order as proposed by the Janssen model. After an external alert, the driver disengages from the 20 questions task, then orients to the driving task and return back to non-driving task. The driver interleave between the driving and non-driving task in this pattern, then suspends the 20 questions task and finally take control of the vehicle. Whereas in suspension pattern, participants stopped their engagement in the non-driving task and immediately resumed control of the simulated vehicle. Participants did not interleave between the non-driving and driving task in suspension pattern. Our first research question was, do drivers interleave the non-driving task and driving task as they take back control of an automated vehicle? Yes, we found the answer to this question. Among 110 takeover instances, driver interleaving pattern occurrence was 64.5% and suspension pattern occurrence was 35.5%. Takeover time was calculated in 15 seconds and 30 seconds takeover request time conditions and for 2 different patterns. Given higher takeover request time, participants took longer time to take control of the vehicle. In 30 seconds condition, participants with interleaving pattern took 21.06 seconds to take control of the vehicle. The shortest takeover time was seen in 15 seconds condition suspension pattern, which is 8.25 seconds. To answer our second research question, how do participants use their interleaving time and how does this depend on time available to take back control? We analyzed what type of actions do participants take in the 20 questions task game after the system issued the pre-warning and before taking control of the vehicle. There are 4 possible options. Participants stopped the 20 questions task after the alert or continued guessing the item but did not guess, or finally guessing the current item and stopped, or continued the 20 questions task, made a guess of the current item and started the new item before switching to driving. In 30-second condition, we observed interesting fact that in 11 instances, participants attempted new item after finishing the current item, whereas in 15 seconds condition, no new item was started. This indicates a clear difference between the 2 conditions. From our research, we conclude that we cannot expect drivers to always shift their full attention to driving immediately after they receive the takeover request or even immediately after they first disengage. We provide evidence to support Janssen model through our driving simulator experiment study. Results demonstrate that the length of time available for takeover influences the order of transition stages during takeover and on the 20 questions task performance. Thank you all for your participation and thanks to Automotive User Interface for this opportunity.